Hey everyone, welcome to this Abaqus tutorial. In this video, we dive into a very simple simulation of micro-indentation. So without waste of any time, we want to start with part. So I click on part, let's say specimen, and this one should be axisymmetric, deformable, shell, and this one can be 0.1 because the part we are having here, it's so small. So this is 0.3, this should be 0.3, and this one should be 0.2 millimeter. So scroll button of the mouse. So we have the part here, and we want to create another part, which is the indenter. This one should be axisymmetric and analytical rigid. So we create one like this. The thing that matter here is the angle. According to the Vickers, this should be this should be 68, and this part should be 0.005. so yeah, scroll button. Now we have the indenter. Then it's time to go to the properties. We cannot assign properties to this one, so it's pretty easier. We want to have the other part. So this is the indenter. We want to have the specimen. Oh, I misspelled the name, it doesn't matter. So yep, let's go and create the material properties. Steel general density, we need 7.8 E-9. Mechanical elastic behavior, we have this one 210,000, 0.33 for Poisson's ratio, and the most important one is the plastic, which is the yield. We copy these values and paste them here. So this is all the properties we need. Now it's time to create the section. Though the part is shell, we need to have a solid homogeneous section. I explained that in one of those previous videos. I put the link on the top so you can check it. So we have this section and we assign it here. I uncheck this one in order not to have too many sets. So this is the part we have. Now in the assembly, we want to assemble the part, the specimen, and the indenter. Alright, now we need to translate them. So I want to translate this one to here, and I select this one, and from here I remove this selection and I select this one, and I want to translate this one. So this one done, I click here, and now I click this one, replace all, to have the specimen, and I place it here. Scroll button. Now we have the indenter, which is actually the half of the indenter because we have a symmetry here, so it should be like this, an angle here. So this is the indenter and this is the specimen. Now the assembly is done. Let's go to the step 1, static general. Time period should be 1.5, NLGM should be turned on, and also we need this one here, so we accept these values. This one should be 1 million, 0.11 A minus 9, and this one is 0.1. So the initial increment size is 0.001, minimum is 1 e minus 9, and the maximum is 0.1. So this is the step. Now we need a reference point, so I create the reference point here. Let's say 0 and 0.022, somewhere around here. Yeah, we have the indenter here, and we create a set. So from set manager, I create a set RP, continue, I put this reference point here, so we have our reference point, so that in the history output manager we can have RF2 and U2 here, and here we have the RP. We can have this one at 5, so yeah, this one should be 5. Yeah, that's cool. Now it's time to go to the interactions. So let's create the first interaction, which is the surface to surface. Should be from initial. We select this one, scroll button, the yellow one, and we select surface. This surface should be selected, scroll button again. So we have a surface to surface contact because there's a contact between the indenter and the surface, and the master should be the indenter. And here we need the contact interaction property, so we create one here. It should be interaction property contact. I select the tangential behavior, and we assume that there's no friction between the two. And also we can have the normal behavior with the form of hard contact. So I click OK, and we have the interaction. Now we need another interaction, which is the rigid body. We have to have the rigid body and say this indenter is rigid. So I click the create constraint, and from rigid body I select rigid body here. So we need a reference point here. I select this reference point, and from here analytical surface I need to select this one, scroll button, and the yellow one. So if we click on OK, we say this one is rigid and assign to this RP point. So everything is done here. It's time to go to the load. So from here I want to create a boundary condition. So I click on create displacement and rotation. I select this part and only check on U2. We have to create another one, boundary condition 2. I select this one and I select U1 and U2. So if we fix them on U1 and U2, this one is only fixed on U2, means the degree of freedom is 0 and cannot move in that direction. And also we want to create something for the load. So from this displacement I select this one, RP point, click on done, U1, U2, U3. So it is created. Now it needs to be changed. So I click on step 1, double click on this one 0, 0 and minus 0.0009, and we need to have an amplitude here. So amplitude 1 should be 0, 0, 0.51 and enter 0.1. I'm sorry, 1.5 and 0 here. Now this is the amplitude we have. Now we need to select the amplitude, so don't forget to click on this one, otherwise you only have the loading curvature. So I click OK. Now the load and boundary conditions are done. It's time to go to the step. Here we can see the edges, but first we have to go to the part. So I use this edge and this edge. Scroll button. We should have a single bias, and we want to flip both of these. So we by holding shift we can select them, and as you see here the bias is different, and the number of elements should be 60 on this side. And now we want to select this one and this one. Scroll button. Oops, one of them is not selected, so I select this one holding shift, and this side is kind of tricky, or I can select all of them and deselect this one by holding control and selecting this one, and we can have the seed edge, and let's have 40 elements on this one. Now let's see how the mesh goes. Yeah, it's not bad. For the best results it should be even lower than that, but yeah, because this is the tutorial, so it's okay for now. So everything else is done. Now it's time to go and create the job. Let's say indentation rigid, or you can say a rigid, okay, which is analytical rigid. Continue. Okay, now I submit the job, and like before I come back after the job is completed. Alright, the job is completed. Now we can go and see the results. So this is the results. Yeah, this is the final step. Let's go. Okay, here you see some elements are distorted, so if you want to have a simulation you want to avoid this element distortion. So let's see. Okay, it goes and apply a force, then it stops and goes down, goes up in order to have an unloading. So yeah, so we have loading here, applying force and waiting, then here we have an unloading. Okay, we can have it here. If you want to take in a snapshot, it's better to go from option common and have the feature edges in order to remove the meshes. And also you can go from here, from the print, you can select the file here. You select the file name, for instance Indenter, and you can select the format like the PNG for instance, and you can click on OK to have an image from it. So it is now is in C temp. And also you can have the from view and annotation part, you can set some of the unnecessary one off in order to have a better image. Okay, now the most important part in the results is to see the force versus displacement. So from here, instead of ODB history output, I would like to select the ODB field output here. So you click on unique nodal, you select U2 and RF2 here, and from edit selection, or you can go from here to have the reference point. So we have U2 RF2 reference point and plot. So as you see here, it is so strange. Now we want to go to operate on XY data and combine then absolute value of U2, comma here, absolute RF2, and plot. Let's see the plot here. Okay, let's take it to the Excel, select edit, select this one and the last one with holding shift. So copy, we can for instance paste it here. We don't need these values, and we can have a plot. So this is the one of the curves that you can get from the actual indentation test. So if you refine the mesh, you don't see these fluctuations here, but here you can roughly see we have a loading part and an unknown unloading part here, which is very cool. And that's it. I hope you enjoyed the video. If you did, please like and subscribe to the channel to see similar videos. In the next video, I'm going to show you a different method to have the nano indentation or micro indentation. So see you in the next video.